Hello, hi. So, like our previous video, I will be again doing another LeetCode question. And yeah, I will not go into my rant story of now how I don't want to do PhD and directly get into the question. So, this question is a very interesting question. It goes by the name Jump Game, and I, for the life of me, cannot do this in the first attempt without, going through solutions or whatever I've done previously. But, anyways, it says medium, but once we understand this question, it is pretty trickily easy, I would say. So it is, I think you can do it using DP. You can also do it using some exhaustive methods, but the method that works best is actually greedy because it is an O of n solution instead of a DP solution or a redundant solution that we can try. So I'll just go about explain how you can do this problem using DP first, maybe if you want that. So if we had to do it using DP and somewhat redundant coding, then I would have to make a sort of a tree where I would explore all my options, right? So I would start off with the 0th node and then which has 3, so it will have 3 options. I can either go 1 ahead or I can go 2 ahead, right? And or I can just go 3 ahead straight up and yeah, and then we will note down what nodes we'll reach. So from 0, so 0 it is the index, and these are the kind of weights that we're putting on our indices to show how much ahead are we going at every step. So I'll just erase this actually, I think. Um, yeah, okay, I'll put a 3 here, right? And now if I go 1 ahead, I will reach 2. If I go 2 ahead, I will reach a 1. And if I go ahead by 3, I will reach a 0, right? And then by similar operations, if I actually no, I would like to erase this part. I'm sorry, I'm really sorry for the kind of mess I'm creating here, but I have decided to go put indices and weights on my arrows, so that's what we'll have to do. So this is 0th index, and if I go 1 ahead, I'll reach the first index. If I go 2 ahead, I'll reach the second index, and if I go 3 ahead, I'll reach the third index, right? And when I reach the first index, I will have 2. So this can and again go one of the 2 ways, that is, it can go 1 ahead or it can go 2 ahead. So if it goes 1 ahead, I will reach my second index, and if I go 2 ahead, I'll reach my third index, right? Similarly, when I go by this, when I reach my second index, that is 1, I can only go 1 ahead, and I'll reach my third index. And of course, when I go to my second index, which is 1 again, I will reach 3. So now you see the third index here is coming out to be in all the cases, but the problem with the third index is that it's the 0, and so it is very evident that regardless of which path I take, I am always going to end up in a 0. And because of that, this solution will not be viable for my question here, which quite clearly says that I have to reach the end, the last index, right? So from that perspective, a thing that we should keep in mind, I would say, is that we can use DP to kind of do it easier. So basically, every time I'll demarcate all my indices of DP. So I'll label my indices with false and true. And so if I already have 3 stored over here, and if I have from 3, I have 2 stored over here, so I will mark my second index false. So I won't have to explore this option. I will mark my first index false. So basically that will help me trace back to 0, and the 0th index will also be false. And that will solve our question. It will give false for all of the indices. And from there we can say that you cannot arrive at the solution. However, an easier way to come up with this solution is just this. So the easier way to come up with the solution is check the previous value. So supposedly, if this wasn't a 0, let's just say for example's sake, this was a 1. So I know that if I have a 1 before the 4, then I can obviously go to the 4. Like the 1 will obviously point towards 4. So now my new thing that I have to check is a 1. Now if I have 1 before the 1, I know I can always reach this 1. And similarly, so on and so forth. If I have a 2, I know I can always reach this 1. And if I have a 3, I can always reach this 2. So we're greedily changing our last index. Instead of keeping it to the last index of the actual array, we are going to be passing on the flag. So if it is 4, I'll take it 1 back. Then if it is 1, I'll again move it 1 back. So it is somewhat like a recursive way of seeing if your previous index is going to reach the next one and then making that the actual target. I will now code this up a little bit so it makes more sense, right? Yeah. So the aim of the problem is to kind of pass the flag, right? So for that, I will first start off with the very last element. So suppose I name that flag is equal to len nums minus 1, because the indexing. So I go for I in range, len nums minus 2, comma minus 1, minus 1. So now I will check if I plus nums I is kind of greater than or equal to my flag, right? So my flag is 4, so the 4th index. So I want to check if I plus minus I. So I in this case is 3, the length of the nums array is 5, minus 2 is 3. So we're checking the element here at index 3 and we're seeing if 3 plus the value at 3, which is 1, is going to give you a last index, right? Kind of like how I said pass the flag. So is greater than equal to the flag. So if that makes any sense, I will now move my flag to 1. So how would I do that? Flag is equal to I. Does that make sense? So now I just have to check if my flag is equal to 0. So if my flag has now become 0, so that means I have reached the last element. So it is possible to move from the last element to the finalmost element. If I have reached the last element, I will return, or we can just do return. So let's try seeing if this works. Okay, so we have our cases accepted. I hope this is well explained and you could understand what I meant. Yeah, and so our solution is pretty good right here. We can see that it works. That will be all for this session. Thank you so much. Yeah.